All right, for this problem, we're told that a company's revenue from selling X smartwatches is given as R of X equals 2100X minus 4X squared. If sales are increasing at the rate of 30 units per day, how rapidly is revenue increasing in dollars per day when 200 units have been sold? All right, so for a problem like this, I like to start off by defining my variables, making sure I know what I know, and writing out explicitly what each of these variables mean. So I know that R is revenue in dollars. I know that X is the number of smartwatches, so the number of units sold. And then we need a new variable in this because we're asked to find how rapidly revenue is increasing in dollars per day. So we're introducing an element of time in this. So for these related rates problems, we're also going to have this variable t, which is time in, let me write this as time in days. Oops. In days. All right. Well, that means that what we're trying to find is the rate of change in our revenue with respect to time. We're trying to find the change in the revenue in dollars per day. So it's the change in the revenue with respect to our time. That's what we're trying to find, and it's going to be in dollars per day. And then we know the change in X with respect to time. We're given that the sales are increasing at the rate of 30 units per day. So X is the number of units sold. So the change in the number of units sold per day is the derivative of X with respect to time. And so this is going to be 30 units per day. And then we also know X. We're told that at this point, the number of units sold is 200. So X is 200 units. Notice with all of these, whenever we're talking about a derivative, it should always be a rate of change. It's something per something. Whereas if we don't have a derivative, we just have X, this is just in total number of units. It's not a rate of change. Okay, so now our next job is to take the derivative of everything in our given equation with respect to time. Now remember, because we're taking the derivative with respect to time and not with respect to X or with respect to R, we always have to use the chain rule and multiply we can treat everything as if it were a t, but then we have to multiply by the derivative of each piece with respect to time. So let's start off. The derivative of R with respect to t is dr over dt. The derivative of 2100x with respect to time is going to be 2100, but then multiplied by the derivative of x with respect to t. And then the derivative of 4x squared, negative 4x squared, is going to be negative 8x, but again multiplied by the derivative of x with respect to time. All right, so now we know that dx over dt is 30. and we know that X is 200, so we're going to plug that in. So the rate of change in our revenue at this particular point is going to be 2,100 times 30 minus 8 times 200 times 30. And then now it's just a matter of doing this math. 2,100 times 30 would be 63,000 minus 30 times 200 would be 6,000 times 8 would be 48,000. And so 63,000 minus 48,000 is going to be 15,000. And again, that's in dollars per day. So at this point, when revenue is changing at 30 units per day and we've produced 30 units, our revenue is changing at a rate of, is increasing at a rate of $15,000 per day.